Hey guys, this is Mrs. Tran-Bloom. I'm just kind of having some issues with my recording. Hopefully it's not going to be on this one. We're like about 8 minutes down. My voice will it goes quicker than my writing. So I'm not sure how to fix that. At this point I kind of don't know what to do. So hopefully this video, it didn't do it before when I was recording at home, which where I am at right now, but all of a sudden it's now doing it, so I don't know what's wrong. So I'm trying out this video and hopefully it works, okay? So 5.3, exponential functions. This is really important, right? There are some vocabulary and some theorems that we're going to talk about. Super important vocabulary and theorems. So first, law of exponent theorem. Law of exponents. If s, t, and a and also b are real numbers. Remember, real numbers are pretty much everything you can think of except imaginary. With a being greater, which is positive, okay, and b being greater, which is also positive. So a is positive as well as b, okay, and also b. Then here are the rules from Algebra 2. Okay, you have to remember these rules already. I'm not teaching you something that you've already learned, but I'm just going to review this with you. When you have a to the s power times a to the t power, because the two bases are exactly the same, we add the exponents. Okay, a to the s raised to the power of t, power to the power, we would multiply the two powers. A times b to the s power, we can actually distribute the s. So it becomes a to the s times b to the s. Okay. We are not going to add the s's because base a and base b are not identical. 1 to any exponent equals itself. A to the negative exponent becomes 1 over a to the positive exponent, or 1 over a to the positive exponent, because as you remember from the previous rule here, 1 to any power is itself. So 1 over a to the s is identical to 1 over a to all of it to the power of s. A to the 0, it's always 1. Okay, so you can have 1 million to the 0 power. That will always give you 1. Alright, next law. Exponential function. An exponential function is a function of the form f of x equals c times a to the x, where a is a positive real number, which is greater than 0, and a can never ever be 1. C can never ever be 0, okay? And it's also a real number. So all of these just talk about in real number. The domain of f is the set of all real numbers. So that means this is really important. Anytime you see an exponential function, the domain, it's always all reals. So you don't even have to think about it. The base a is a growth factor. Okay. Well, we're going to talk about the growth factor or decay. And because f of 0 equals, this is your input, equals the initial value times your base to the 0 power, a to any number to the 0 power, it's always going to be 1. 1 times c is c. We call c the initial value. Okay, so a couple examples would be, so i.e. f of x equals 2 times 3 to the x power. This is the growth equation. It's a growth equation because the larger x I substitute in, for example, if x is 1, 3 to the 1 is going to be 3. 3 times 2 is 6. If I substitute 2 in for x, 3 to the second is 9. 9 times 2 is 18. As you can tell, if x is getting larger, then this is a growth factor. Now what happens if x is going to be negative? Okay, so if x is negative 1, then you would have 2 times 3 to the negative 1, which is by definition 2 times 1 over 3. Oops, you can't see that. This is now 2 over 3, okay, which is smaller. How about when x is negative 2? Then I would have 2 times 3 to the negative 2 equals 3 to the negative 2 by definition previously stated is 1 over 3 to the second. So that's 3 to the second is 1/9. 1/9 times 2 is 2 over 9. Okay? Which is getting smaller. So when x is negative, this function is actually a decreasing or decaying function. But when x is positive, then you have an increasing function. Okay? Alright, e, an awesome looking number, right? The number e is defined as a number, the expression 1 plus 1 over n to the nth power, as n approaches a really large number, infinity. In calculus, this is expressed using limit notation as e equals the limits of n approaches infinity. Okay, so e equals the limits of 1 plus 1 over n to the nth power as n approaches infinity. Okay, so as n approaches a really large number, then this equation here becomes closer and closer and closer to e. Alright, so what I would like for you to do right now is, I would like for you to use a calculator. Okay, so in your notes, use your calculator and find the e button. Find e button. Okay, and I would like for you to write 2 locations where your e button is. So when I check your notes, I need to see these. Okay, go and find your e button. Alright, now that I need to go get my calculator, hopefully you guys have written down where the 2 locations are. Okay. If you need extra help, I can point you to the location. The first location is, I'm going to move it up, is this ln button. Can you see that right there? This is ln button. So the inverse of ln, it's e to the x. So it's under log, which is, let's see, 1, 2, 3, 4, 5, 6. So 7, the 7th button down on the right, on the left. This other button, it's actually here underneath pi. So it's the 3rd button down from the right. Okay, so those are your 2 locations, so you can write in those. Okay, so example 1. Using a calculator, evaluate. So what I'm going to do is I'm going to do A and let's see, A and E with you, alright? And then your job is to use your calculator to do the rest. And if you're faster than me, you can do all of them on your own. So here we go. Using the calculator, evaluate 2 to the power 1.4. So 2, I'm going to enter 2, okay, caret 1.4 equals, I would like you to round that to, you know what, don't round, write it all out for me. Okay, yes, I asked you to write it all out. Here we go. 2.639015822. So that's what we get for 2 to the 1.4 power. So now I'm gonna do e. So let's do 2 caret square root of 2 gives me 2.665144143. Okay, so do me a favor, your job is to complete B, C, and D. So pause it right now for me. Pause it, pause it, pause it, and then finish those. Okay, so these are now on your own. So hopefully you're pausing right now. Alright, let's go and see the concept. Now, anytime you see the exploration or seeing the concept, these are pretty much on your own. So the direction sets, graph y equals 2 to the x, and y sub 2 equals 100 to the x on the same screen. What should your window be to see both functions? What do you notice about the graphs? Okay, so if it's asking for what your window be, I need you to write in here your x min, x max, y min, y max. All right. I would like for you to sketch those functions out over here. Label which one is the y sub 1, which one's y sub 2. And it says, what do you notice about the graph? So I'm going to help you out with, I noticed, okay, something about y2 that's different from y1. Something about y2 that's the same as y1. Okay? Something that is interesting. Okay, where is it decreasing for both? Where is it increasing for both? Or are they both constant? Okay, so this is all on your own for this piece. Okay, and then so go ahead and hit pause again, so that way you can finish that up before I flip over. Thank you for hitting pause. All right. Now that you're back from pausing, let's read this box right here, which is super important. Properties of exponential function. F of x equals a to the x, where a is only greater than 1. Okay, like 1.1, 1.2, anything that's bigger than 1. 1. The domain, it's always all real. Doesn't matter what exponential function we're talking about. The range is the set of positive real numbers. That means it's going to be bigger than 0. Okay, this is bigger than 0. Okay, 0 is neither positive and negative, so that's why we're not including it. There are no intercept. The y-intercept, it's 1. The x-axis, which is y equals to 0, it's a horizontal asymptote. So we're back at horizontal asymptote. So check out the dashes here. Okay, that's your horizontal asymptote at y equals to 0. You have y-intercept, when x is 0, y is 1. F of x equals a to the x, where a is only greater than 1. It's an increasing function, and it's always 1 to 1. So if you look at this, it's increasing as x is increasing. The graph of f contains 3 points, and these are super important, okay? When y-intercept is always, doesn't matter what function you have, it's always 0, 1. When I put 1 in, a to the 1 power is always a. Okay? When I put negative 1 in, a to the negative 1, it's always 1 over a. So these are the 3 points we're going to be using all the time. 3 points we will use. Alright? Number 6. The graph of f is smooth and continuous because it's a function. These are the definition of function, with no corners or gaps. Okay? So this is a little quick sketch here of an equation, y equals a to the x, where a is greater than 1, which is a can be 1.1 to the x, 2.5 to the x. It doesn't matter what it is as long as it's bigger than 1. And the domain is always all real. The range is only positive. There's a horizontal asymptote at y equals to 0. Okay? Alright. So our next scene, the concept. Graph y sub 1 equals 1/2 to the x. Now keep in mind that this is a right here, and a is not bigger than 1, so it does not contain to the stuff that we talked about earlier. Y sub 2 equals 1 over 10. On the same screen, what should your window be? So in this case, I would like for you to graph it out. Tell me what x min and x max. Okay, y min and y max. Okay, sketch it on the same screen here. Label which one's y1, which one's y2. What do you notice about the graph? I noticed, okay, something about y1 and y2. How are they the same? How are they different? What's interesting to you? Are they always increasing? Are they always decreasing? And so on and so on. Okay, so that is your task for right now. So hit pause. Thank you. Okay, so thank you for doing the understanding the concept or seeing the concept above. Now that you have unpaused, let's talk about the next window here. So this window, okay, is talking about when a is between 0 and 1. So 0.9, 1/2, 1/10, okay, which is the check for understanding. not check for understanding, the seeing the concept that you have just completed. So hopefully you understood something from there. So this is just to confirm, okay, what you just explore for yourself. So this one says, properties of exponential function, f of x equals a to the x, where a is less than 1 but greater than 0. So it's still positive, it's just less than 1. The domain would never change. The domain will always be all real numbers, okay? The range still doesn't change. It's still going to be positive. So the range is still going to be greater than 0. There are no x-intercept, just like previous concept when a is greater than 1. The y-intercept is still 0, 1. So again, that point doesn't change. The horizontal asymptote doesn't change either, right? The horizontal asymptote is still y equals to 0. So the first three things have not changed. Now, this is different from above. F of x equals a to x, where a is less than 0, which is still positive, but less than 1, but greater than 0, is a decreasing function and is still 1 to 1. So notice how as x approaches a really large number, y is decreasing closer and closer to x-axis, which is 0. It would never be quite 0, but it's going to get very, very close. The graph of f contains 3 points. Same exact 3 points. Okay, there's nothing going to change about those 3 points. The graph of f is smooth and continuous with no corners or gaps. Okay, so this is just a definition of a function. So all of those things are exactly the same except one, number 4. Okay, so when a is less than 1 but greater than 0, you're going to have a decreasing function. When a is bigger than 1, you're going to have an increasing function. All right. Okay, so exploration, which is seeing the concept. So if you look at this one, similarly to the first two, graph y sub 1 equals 6 to the x, y sub 2 equals 1 over 6. This is when a is greater than 1. This is when a is between 0 and 1 on the same screen. What do you notice about these two? Okay, so I would like for you to answer I, notice, and then compare those two for me. What is it that they have in common? What is it that they're different about? Okay, write a little paragraph that will help you in the future understand those concepts when a, the base, is greater than 1, when the base is between 0 and 1. And once you're done with that, this is going to be the last piece of our lecture. Okay, so let me look for a joke. Let's see. All right, here we go. Why did the dog jump into the river? It wanted to chase the catfish. Ha 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 ha. A cat, remember? But it's a fish. All right, have a good day.